Welcome to another day on the Journey Chez Chem. As always, you have 2 warm-up questions to do, and because we're starting a new topic, you're going to have to look in a textbook to find the definitions. Just do the best you can, and we'll talk about it soon. Number 1 asks for the difference between a qualitative and a quantitative observation. Qualitative is descriptive, like color, does something give off a gas, is there a solid formed? Quantitative is by measurements, where you have numerical values that you have collected, so that would be quantitative. Number 2 asks about scientific notation, and maybe you need a little bit of review for scientific notation. Scientific notation is all about the decimal, and we're moving the decimal. So you need to write this down. First of all, if a number is larger than 1, it has a positive exponent. If the number is less than 1, it has a negative exponent. So the first number was 0.00050, and we have a number that is less than 1, so we will have to move this decimal 4 places behind the first whole number, and the answer would be 5.0 times 10 to the negative 4th. And we'll learn why I had to put that 0 there. The second question was 0.075. That number is also less than 1, so it would be 7.5 times 10 to the minus 2, because I moved it 2 places. For C, I have a number that is larger than 1, very much larger than 1. And so I have to move this decimal a long way. 3, 6, 9, and 10 places. So it will be 2.06 times 10 to the 10th. For D, the number is 5,000. And so I have to move that decimal 3 places. So it is 5 times 10 to the 3rd. That is the answer to number 2. Now we need to discuss the lab that we did last week. And we have to draw a solubility curve. So you need to find in a textbook the theoretical solubility curve for potassium nitrate. And potassium nitrate would be KNO3, and that's also given to you in the beginning of the lab. You will find the theoretical value for the theoretical curve in a textbook, and you'll need to write that into the lab using graph paper. So you'll have to take some of the points out and plot them. But for our purposes right now, we know that this curve goes approximately in this direction. Now that would be my theoretical. Then I need to take my data points that I have collected and change them. They were in grams per 5 milliliters, and we need to find out how many grams that would be in 100 milliliters. So we need to cross multiply. The first one was 0.5 grams in 5 milliliters, and so when we work out the math, we find that that is 10 grams. And so my second data point would be 20 grams, then 30 grams, and 40 grams. However, you need to show your math in your lab write-up. So you'll need to do this math for every one of your data points. So if I'm going to take my data and plot the points, my points could be all over the place because they're experimental. So it depends on my experimental technique and at what point I saw the crystallization. And that was a little bit difficult. So we are just going to do approximation that one of the point at 10 grams was approximately 22 degrees, and that another one was over here, that would be 20 grams, and then we had another one at 30 grams and another one at 40 grams. And let's say that one was similar to that one. So because these are experimental values, I'm going to draw what's called the line of best fit. Now, a graphing calculator can also do a linear regression to give us a nice curve and based on these points, but what we want to do is just look at it and get our best line. And we are not going to connect the dots. We never connect the dots. So my line is going to go approximately here. So that would be my best line, and I'm going to circle my data points. So those are some of the requirements that you need to do in your lab. There are 3 other curves that you need to draw, and that would be sodium chlorate, sodium chloride, and potassium bromide. So you also need to put those theoretical ones onto your curve, and you can also get those out of a textbook. So that should help you in writing up this lab. Now, on the worksheet that I want to show you how to use significant digits and which numbers have significant digits and which numbers are not significant digits, the problem really arises on the zeros. So all regular digits from 1 to 9, I call them regular digits, are significant. What the problem is how do we handle the zeros? And the reason that we have significant digit rules is so that everyone in the whole wide world doing experiments is going to handle the numbers that they get in their experiment the same way. So if I have a number like 5,000, that only has one significant digit. The other these zeros are important. If I owe you $5,000 and I only give you $5, you're not going to be real happy about that. So these are important, but they're not significant. So if I go to a concert and it calls for, they say there's about 5,000 people there, well, there could be 5,322. But they're rounding it to 5,000, so there's only one significant digit in this number. These are called trailing zeros. Now, if I put a 0.0 here, then this measurement was made to the 10th place, and they all become significant. If I have zeros between 2 significant digits, then all the numbers are significant between those 2 regular digits. If I have a number that is preceded by a 0, then these are just placeholders and they are not significant. So the 1 and the 5 are significant. If I had a 0 here, that would also be significant because the tool that measured this is to this accuracy. Now let's say, for example, they were measuring blood sugar and the blood sugar was to this accuracy. These 3 are significant, but these are just placeholders. This 0 offsetting this decimal, these are all not significant. No matter how many zeros I would have in front, they're not significant, they're just placeholders. If, however, I put a 1 in the front or any other regular digit, then they all become significant. So significant digits is how we handle numbers. The critical part is how do I handle those zeros? So if I have 50, that's only one significant digit. If I have 50.0, that's 3 significant digits. So what I would like you to do is worksheet A, and then for each one of the numbers, write how many of the numbers are significant. So if you're given this number, you would write 3. If you were given this number, you would write 4. So please go through those exercises, and your facilitator has the answers, and you can go over it then. So that was some fun, huh? Learning how to handle numbers, and we'll see you tomorrow.